The presentation is really going to be focusing on the research aspects of our organization. We are in the industry, we are not an academic institution per se, but we'll look at what we are doing as far as research is concerned so that it's actually relevant to the forum we are in. But before I go through that, as a usual custom, I'll just quickly go through the company overview, and then I'm going to look at the role and trust of research and initiatives and infrastructure that we have around research aspects. On the overview of the company, we are a state-owned company, and we primarily provide communication services, broadcasting and connectivity. We have 300 high sites across the country, and we have got a 9 fleet of satellite transponders. We have got a ring in Gauteng of high-speed fiber, and we've got a number of wireless broadband sites. We are currently also looking at solutions for border control. The services that we provide, I've already discussed that. It's broadcasting and multimedia services and ICT services, including broadband, data center solutions, and wireless broadband. In summary, our capacity consists of teleport. We have the largest teleport in satellite teleport in South Africa. We have 400 wireless access sites in South Africa. We've got a data center located in Johannesburg next to Soweto. We have got a fiber ring in Gauteng, and we have got an operations center which is 24/7, 365 days. Just now to go to the role, our role in research and innovation, we call the department. The department was formalized in 2018, and the reason why it was formalized separately from any other department is so that it is within the national system of innovation in South Africa, and it can collaborate with other entities internationally and local and academia. And the way we have structured it, or we contextualize it with the academic environment, the first part is we consider basic research, we consider applied, we consider industrialization and commercialization. Our focus, obviously, as an industry and a company, is on the applied and industrialization, but we also work with the academic institutions to look at basic research. We also work with research councils such as CSIR in order to harmonize and combine basic research and applied research, and as well as industrialization. So that's the context, and I think it's also important to look at the context around the business cases. As an industry, again, profit center, whatever research that we are engaged with, we have to look in context. So the first context is which applies also in basic research is what is possible in terms of scientific advancement and ecosystem and technology. We have the technology to achieve particular research to a point where we can industrialize it. What is feasible? What technology do we have? What is economics? What are the financial resources do we have? What is desirable? So we might have the ecosystem, you might have the technology, you might have the financial resources, but it might not be something desirable from a socio-economic point of view and politics point of view. Ethically, it might not be something desirable. Then the last part, is it worth it? Which basically talks to what are the potential results, what is the impact, what is the scale. So it wouldn't make sense to spend a lot of time only to find that we can't have the right scale. Obviously, it requires a balance, and so we do the balance, and that's why we collaborate with research councils and academia and other researchers. Specifically, our focus is around future networks and industrial environment in industrial environments and smart villages. So is investigating how we can take the communication infrastructure, advanced communication infrastructure, into smart villages, not just smart cities, but also peri-urban and farms, agricultural lands. How do we take our networks there? Of course, that links to edge, fog, cloud, and open compute architecture. We look at that. We also have a strain around data analytics and machine learning and artificial intelligence. We expand, obviously, our innovation capacity, as I've said, using academia as well as research councils. So now I'm going to talk specifically around initiatives and what we have done so far and what we can provide for other institutions to have access to. The first aspect is 5G. We have deployed a trial site or sites. We have got 2 trial sites for 5G. And in particular, what we have already done is testing the multi-operator core network framework with the local, one of the local mobile operators, which was successful. So in the previous year, that was our focus. So what it does, it allows us to create an environment where infrastructure can be shared among operators. And a lot of infrastructure elements can be shared. We are also working on radio access network virtualization using cloud. And then the next aspect, obviously, is 5G, combining it with cloud. And part of it is the virtualization. But part of the combination of 5G and cloud is also to create a node or nodes so that we can create edge computing and we can allow 5G nodes to be connected directly to the cloud to allow the speed and to reduce the delay for different operations, especially when we are looking at autonomous operations. Then we are also looking at 5G in broadcasting, specifically looking at the enhanced mobile broadcast services, which is specified by 3GPP. We're also looking at advanced industrial 5G and IoT use cases for automobile and industry and other autonomous operations in industries and manufacturing. We are moving towards also looking at requirements for 6G so that we fully have environment for autonomous vehicles. Another initiative, just before I leave the 5G side, this just gives the setup that we have currently, which connects to our sites and our core with one of the mobile operators. By the way, also just to mention that we are making an arrangement so that academia can be able to be connected to our site and they can do studies and investigations. In particular, at the moment, we are looking at transport layer level, not so much on the physical layer, in terms of allowing industry, academic and research councils to utilize the infrastructure. Obviously, is the easy entry into the environment, and that's why we're starting with the transport layer. I must also say that in terms of 5G, we have already a contract that we are doing, which is now on the commercial side. We will be putting a private network for a government department. But what it does, it also increases our ability to do further research and to do some advancement around research. I'm going to jump this slide. It was just an attempt to show some of the tests that we have done around 5G broadcast, which allows us to do one, contribution using 5G, two, to provide the distribution or user access at 4K standard for live broadcasting. So the picture was quite good, and I think I will send the link so that people can be able to look at the test. Then we also worked around cloud computing, data analytics, artificial intelligence. Currently, we have already developed a technology demonstrator for intelligent predictive alarm model. We are working with CSIR on technology for technology demonstrator for natural language processing, especially for customer sentiment analysis. The applications that we are looking at is to be able to use NLP for network proactive maintenance or repairs. We can use actually social media and natural language processing to do that. We're also working on intelligent learning platform using chatbot with AI, which we are busy with. Just again, another initiative is around antenna systems. We are looking at Lundberg lens antennas. What it allows, these are quite a huge antennas that can cover a large radius, a large distance. But most importantly for us, we have got high sites, so it becomes possible to put it in high sites and to cover a large area. They are quite expensive, but the trade-off is that they can cover a large area. So in rural areas, they can work best. Obviously, you do require some level of density. So we're looking at investigating such antennas, what it provides in a 120-degree sector. It further reduces that to other subsectors, about 48 subsectors. So you can do a lot around manipulating the sectors and actually increasing the throughputs. So that's another initiative that we are busy with. I just left this slide, which was linked to the predictive alarm system. This is just outcome of that project. Currently, in a way, we can be able to predict alarms. What we need to do is to take this further to say that from the alarms, can we predict performance? Can we predict faults? Can we predict, or can we able to use the predictions to plan for maintenance, to plan for repairs, for resource planning, and so on and so on. So these are some of the initiatives that we are busy with, which basically covers 5G. It covers the cloud and services that we are putting over 5G and over the cloud. Thank you so much.